Dr. Easley is always looking for a way to make a buck. And so this time he has set up himself an alligator distribution center. Alligators evidently need to be distributed around the country, and so Dr. Easley is meeting a need where he sees it. He currently hires 2 employees, and their job is to load the alligators into trucks. He is considering whether or not he wants to put in a lift that will do this work for them. If he puts in the lift, he can get rid of one of his employees, right? So he's trying to figure out, is it worthwhile to put in the lift or not? Which is going to be a better thing for him? So it says, the present day value of the cost savings Dr. Easley can achieve by choosing option 2, that is putting in the lift, versus option 1. That's what we're supposed to try to figure out. That means that we have to figure out the cost of doing it one way, and then also the cost of doing it the other way. Okay, so let's go ahead and start with option 1. And the thing with option 1, is we're going to look at just the amount of difference relative to option 2. So what is the cost for option 1 relative to option 2? Well, the difference is 1 employee, right? So if we figure out his cost for option 1 relative to option 2, we basically just look at the cost of 1 employee. Okay, so how do we do that? What would the cash flow diagram look like? Okay, each laborer costs him $1,200 per month, paid at the end of each month. Okay, how long is this project? Okay, he's going to plan on using this thing for 4 years, and at the end of 4 years, he's going to scrap it. What you got?
Were you writing or no?
I'm not writing.
Oh, okay.
Okay. All right, so what we're going to do is put this timeline on here for 4 years. Okay. $1,200 per month paid at the end of each month. All right, so I'll tell you what, we'll just show the first part of the series here. So here's the first month, and at the end of the first month, we have $1,200. 0, 1. Does anything else change? Okay, looks to me like that's going to be the cost that we evaluate for option 1. So we go all the way out to month what? At the end of 4 years, 48. And we have this $1,200 cost at that time too. Okay, and we're supposed to do this based on present value. Okay, so P given A for this, P is equal to 1,200 times what? Okay, we're supposed to do an annual interest rate of 4.5 compounded monthly. So we basically take 1 plus 0.045 over 12. That's how we get a monthly interest rate. And how many times do we have to do that? 48 of those payments. Subtract 1, put this over, again, a monthly interest rate, multiplied by 1 plus, again, that monthly interest rate, to the 48th. Okay, so the present cost of keeping the employee is going to be found with that calculation. So I put 1,200 times 1 plus 0.45, 0.045 I should say, over 12. This raised to the 48th minus 1 over 0.045 over 12 times 1 plus 0.045, we do it this way, 0.045 over 12 raised to the 48. Okay, so the cost of keeping the employee for the 4 years is going to be equal to $52,623 and 53 cents. Okay, so far so good. Let me store that into A because I think I might need it later. All right, now what? Option 2. Okay, so for option 2, we drop this employee, the cost of this one employee, but what do we pick up? A few costs of other things, right? So again, here's the timeline. Okay. Let's see. He has an energy cost of 19 cents per kilowatt hour, all right? And so that's kind of the cost of energy to him. What else do we know? Okay. The lift converts electrical energy to lifting energy with an efficiency of 30%. We also know that it needs to lift an average of 1,000 times per month. Okay. All right, so then that's the other thing, is the initial cost of lift including installation equals $12,000. That one's easy to put on here, right? 12,000. Okay, that's in year or in month 0. Okay. What do we put in month 1? We have to figure out what is this energy cost that he's got now, now that he's got this lift in there. Okay. So he has a weight of 8.5 kilonewtons. That's the lifting cab plus the payload, and has to lift that 1,000 times per month. So what's the energy cost per month? Okay. Well, it'll be 19 cents or I'll kind of do this down below because I don't want to mess up my space of doing my cash flow diagram. Let me do 19 cents, which is $0.19 per kilowatt hour. Okay. Now think about a kilowatt. What is a kilowatt? Okay. What is a watt? Okay, it's voltage times current. What else is it? Joules per second, right? So we have 1,000 joules per second is a kilowatt, right? So we have 1,000 joules per second. That takes care of my kilowatt. And actually I need to put that down here, and I need to put a kilowatt up here. What does that allow me to do? Okay, gets rid of the kilowatts. Okay, what can I do with hours and seconds? How many seconds are in an hour? 3,600 seconds in an hour. Okay, I need to get rid of the hours. So what do I do? So what does multiplying by an hour per 3,600 seconds do for me? Okay, cancels the hours, cancels the seconds. Okay, now what I have is 19 cents per certain number of joules once I multiply those in together. Okay, well that's helpful. Now I need to figure out how many joules. How many joules of energy do I need per month? How do I figure that out? Okay, we have 8.5 kilonewtons, right? So 8.5 kilonewtons, how high do I have to lift the 8.5 kilonewtons? This one's maybe an easy one to let get by you. It gives you a height that you have to lift it. Okay, force times length is what? Energy, right? So if I go ahead and I put in here 8.5 kilonewtons times 133 centimeters.
Wait, I'm sorry, where are you getting the 8.5 kilonewtons?
Okay, 8.5 kilonewtons comes from right up here. It says that the amount we have to lift for that whole thing is 8.5 kilonewtons, and we're going to have to lift it 133 centimeters. Okay? And then how many times do we have to do that? 1,000 times per month, right? So that represents an amount of energy that we have to expend on lifting this thing. Okay? Now, in order to get all the units to jive, what should I do? Should I convert my kilonewtons? 8.5 kilonewtons. Maybe I put kilonewtons down here and put 1,000 newtons up here. Okay. Now what? Should I get rid of my centimeters? 100 centimeters in a meter. Okay, this is the number of times we have to do it per month. Hashtag of times per month. Okay? Because that represents the total amount of energy per month that you got to spend on this. All right. So now what? Let's look at how some of these units cancel out. You got kilonewtons canceling kilonewtons. You got centimeters canceling centimeters. What else do we have? What is this Newton meter? Okay, a Newton meter is a joule. Would you agree with that? So that allows me to cancel newtons and meters, and it allows me to cancel joules. Okay. And what do I end up with? Dollars. Do you agree with that? Okay. So there's some other kind of cool stuff we can do here. I can cancel one of these thousands. Right? And get rid of that 1,000. One less thing I have to type in my calculator. All right, so let's go ahead and type some things in here. 0.19 times what? 8.5 times 1,000 times nothing. Okay. Divide this by what I have in the denominator. 3,600 times 100. Oh, I missed one. I knew I missed one. What else did I miss? Yeah, the 133 that I had there at the beginning. Okay. All right, so 19 cents per kilowatt hour leads to a cost here of 59 cents a month, 60 cents a month-ish. Okay? Doesn't seem like that's a whole lot, and that's actually probably true. Okay? $0.596 a month. So that goes right here. Then what happens? Okay, we get to sell it at the end for $1,100. Okay, out here at 48, we will again at that time have our $0.596. Tell you what, I'm going to go ahead and store that into B. Okay. And then we have this money that comes back at the end of $1,100 for our salvage. All right. Am I missing anything here? I might be missing something. What am I missing? Did we use this piece of information? This is something that I may have missed. Efficiency is 30%. What does that do to our overall question? Does that increase or decrease the amount of energy that I'm expecting to have to use? It increases it, okay? So actually what I need to do is take this whole thing and divide by the efficiency level. Okay, so what does that do? I can do here is I can take this answer that's in B and I can divide it by 0.3. Okay, so now we're talking about $2 a month. All right, I missed the efficiency in the first place. I'm sorry about that. That was not on purpose. I just forgot about that particular term. But that increases the amount of energy I have to provide in order to actually get the effective amount of energy out. Okay, so 1.988 let's say 1.989 dollars per month. Now let me store that into B. All right, and that means I need to change this up here to 1.989. Okay, so now what? We ready to figure out present value? Present value is just going to be equal to 12,000. Do I need to modify the 12,000 number at all? Okay, it's already in the present. It already happens, it's at 0. Okay, so I don't need to modify it at all. Then what?
Plus the 1.989.
Times 1 plus our interest rate monthly, taken to what? 48 minus 1. Down here I have 0.045 over 12 times 1 plus 0.045 over 12. This taken to the 48. Okay. So far that's how much I have that it costs, but I do get the salvage back, right? So what do I do there?
But that one's actually going to cost you
Subtract, right? This is an amount of money I get back, so I can subtract it from my costs, right? 1,100 times what?
it's going to be to the negative.
Yeah, it'll be 1 plus 0.045 over 12
To the negative, would it be 48?
to the negative 48. Okay. And so let's go ahead and punch this in. All right, I've got 12,000 times B times 1 plus 0.045 over 12. This raised to the 48.
Would that be plus B times?
I think I meant to do plus and then I did not do plus. Thank you. Yes, it would be a completely different answer. All right, here I've got 0.045 over 12. Here I've got 1 plus 0.045 over 12. That raised to the 48. And then we're going to subtract 1,100 times 1 plus 0.045 over 12 raised to the, oh no, you know what just happened? If you have this calculator, you start seeing that big blocky cursor right there, that means you're almost out of characters that you can enter. So I'll tell you what we'll do. We'll take off all of this, and we'll do it in a separate step. Okay? So I'll just figure out that much first. This much right here is 12,000. $87.21. Okay. And I will store that into C. Now what I'll do is I'll take C, and I will subtract from that 1,100 times 1 plus 0.045 over 12 raised to the minus 48. Okay, which gives me 11,168.11. Okay, so what's the difference between the two? Okay, the difference is going to be equal to 52,623, which I believe I had in variable A, minus what? What I just got for my last answer, which was 11,168.11. So that gives me 41,455.42. And so the answer then turns out to be E. All right. What was the hardest part of that question?
Keeping track of all the numbers.
Honestly, the engineering econ part of it really wasn't that bad, right?
No, it wasn't.
That's the only
It's this right here.
Because if you don't remember kilometers,
Right, or I'll tell you that what I've seen a lot of students when they come to me and they want help with this question, kilowatt hours really messes them up. All right, kilowatt hours is the unit that is typically used whenever you get billed for electricity, and that's why it's included in this question, because that's the unit usually typically get billed for as far as energy. It is a unit of energy. It's just not one that, when you're early in your phases of engineering schooling, it's not one you're used to seeing yet. So you can convert it to joules is kind of the big idea there that really helps you out. Yes, ma'am. Yeah, so it basically, this one combines concepts that we had from the mechanics and efficiency part of the course with engineering econ. It's not so much really a statics, but it, you know, right. It's mechanics, more generally speaking, than statics. Okay? All right. Well, good work.